bandwidth on use it is -7. So the minimum value is say -7.5, -7.5, minus of -3 is -4.5. When you draw a line, you get a wide bandwidth. Okay, since we are having 20 as the impedance, we have to give impedance what you are going to match. So since we are giving 20, it was taking as 20 everywhere. We are getting a very narrow response. Now in this bandwidth, I have changed the impedance from 20 to 50, and you can see how the bandwidth response is changing instantly. So the antenna is having a reflection coefficient of -10 dB. -10 dB is a really very good number. Reflection coefficient, if it is negative, means that the amount of signal reflected back is going to be very, very less. Okay, that is very good. So this antenna has a bandwidth of 1.71 to 1.77. It is going to work well. So when it's upright, it is going to have a bandwidth of 60 megahertz. The bandwidth is 60 megahertz. This is a simple antenna two-port analysis, analyzing the antenna. We have designed the antenna first. We have plotted the impedance and reactance. From impedance and reactance curve, we can find two things. One is the resonant frequency. How to find resonant frequency? The point where the reactance becomes 0 is your resonant frequency. And at that frequency, what is the resistance? That's going to be the impedance of your antenna. And that impedance, if it is 50, means you are set for maximum power transfer. But if it is not 50, means you will have loss in, you will have return loss will be high, the reflection coefficient will be high, VSWR will be high. So when you here you see we have plotted the antenna with 20 and 50. Maybe we'll run the code 2 times and we'll plot the 20, right? So here it is 20 and here I'll mark it as 50. So with 20 we will run the code. You will get the answer here. Okay, this is for 20. You can see it is -30. Now we'll run the answer for 50 and you can compare the result. See the result. This is for 50 ohms and this is for 20 ohms. And see the change in result. The bandwidth is becoming larger. Okay, so that is one example we have seen. The first example today we have seen how to design an antenna using antenna analyzer, antenna designer app, and now we have seen how to integrate antenna with RF. So designing an antenna we have done, and we have also measured the S parameters of the antenna. As I told you yesterday, as you travel towards high frequency, you will no longer use Z, you will no longer use Y, H, A, B, C, D. You will not use all these parameters. You will be using only S parameters, because as you travel to high frequency, the reflection, the factors of reflection and transmission becomes even more significant compared to voltage and current.